In the third module, we will cover the first homologous series, which is the alkanes and substituents. In module 3, we will just briefly discuss what we know about the alkanes, and then I will introduce you to the naming of organic chemistry by looking at the names for carbon chains and then also identifying and naming of substituents. We know that alkanes only have single bonds between the carbons. And we also know because of this that alkanes are saturated hydrocarbons. You know how to test for saturated hydrocarbons with bromine water, and you saw that alkanes have a very low reactivity. We also know that the general formula for alkanes is CnH2n plus 2, so double the amount of hydrogens compared to the carbons plus another 2. And if you cannot remember this general formula, just draw any alkane and count the amount of carbons and count the amount of hydrogens, and you will see that there will be double the amount of hydrogens plus another 2. You have seen that we use the ANE at the end of the name to indicate that the name is for an alkane. The first part of the name we call the stem, and the stem indicates the amount of carbons in the carbon chain. In the CAP syllabus, you are expected to know the stem names of 1 to 8 carbons in the carbon chain. If there is only one carbon in the molecule, we use the stem name meth, and you will see that the name for this molecule is methane. The ane tells us that this is an alkane. The meth tells us that there's only one carbon in the molecule. For 2 carbons, we use the stem name eth. ETH, ethane, tells us that this is an alkane with 2 carbons in the molecule. Then, for 3 carbons, we use the stem name prop. So, propane will be an alkane with 3 carbons in the carbon chain. For 4 carbons, we use bute. So butane will have 4 carbons, and the ane tells us that this is an alkane with only single bonds between the carbons. For 5 carbons in the carbon chain, we use the stem name pent. So pent tells us that there are 5 carbons in the carbon chain. Ane tells us that it's an alkane with only single bonds between the carbons. For 6, the stem name is hex. Hexane then tells us that there are 6 carbons in the carbon chain, only single bonds between the carbons. And 7 is hept. Heptane is 7 carbons with only single bonds between the carbons. And then lastly, oct is for 8 carbons in the carbon chain. So 8 carbons with only single bonds between the carbons because it is an alkane. You have to know these 8 stem names. We use the same stem names in the naming of the substituents and also all the other homologous series. Substituents or alkyl groups are the branches on a carbon chain. We use the same stem names to tell us the amount of carbons in the branch, and we use YL instead of ANE to tell us that this is an alkyl group. On the right hand side, I have a carbon chain with any amount of carbons. You can see that it continues up and down. And on this carbon chain, a substituent or a branch may look like this. When we have to name an alkyl group, we count the amount of carbons in the alkyl group, in this case only 1, and we use the stem name to tell us the amount of carbons in this alkyl group. So for one carbon we will use the stem name meth, and then we will use YL to indicate that this is an alkyl group. So the name of this alkyl group will be a methyl. If there are two carbons, we will use the stem name eth, and it will still be a YL to tell us that this is an alkyl group. So the name of this alkyl group will be an ethyl. And in the same way, three carbons will then be a propyl. But what will happen if there are more than one of the same alkyl group? We use di or tri to indicate if there are two or three substituents of the same alkyl group. So if there's one alkyl group with one carbon in it, we give the name methyl to it. Meth, it tells us that there's one carbon in the alkyl group, and the YL tells us that it's an alkyl group. If there are two alkyl groups, each one with one carbon in it, we use dimethyl to indicate that there are two alkyl groups, each with one carbon in it. If there are three methyl groups, we will use trimethyl to indicate that there are three alkyl groups, each with one carbon in it. Let us see what you can remember about the alkanes. Give the name of the alkane with the molecular formula C3H8. You can see that there are double the amount of hydrogens plus 2 in this molecule, so it's an alkane. And because there are 3 carbons, you know to use the stem name prop. So the name of this molecule will be propane. Give the molecular formula of heptane. Now, hept tells us that there are 7 carbons in the molecule, and tells us that this is an alkane, so there must be double the amount of hydrogens plus 2. So it will be C7H16. Complete the following formula for pentane. So it's an alkane, there must be double the amount of hydrogens plus 2. So if there are 5 carbons, there must be 12 hydrogens. And then lastly, which of the following molecules are alkanes? Alright, so you look for molecules with a formula where the hydrogens are double plus 2 the amount of carbons. So the first one is not an alkane. The second one, 4 times 2 plus 2 gives you 10, so that is an alkane. Third one, no. Fourth one, yes. Fifth one, no. So those are the 2 alkanes. If you are an educator that would like to inquire about the use of these PowerPoint slideshows in your classroom, you may contact me at lawsandwonders@gmail.com. Please indicate if this topic was useful to you or not, and subscribe to my YouTube channel in order to stay informed about the release of my most recent videos.